So far in our programs, when we run the program, the same thing happens every time. There are situations where we would like to give the program the ability to execute different code or to do different things based on the data that we are working with. So to illustrate this, let's take a look at a sample program where we are going to work with bank account objects. So we can have customers that have bank accounts. We're thinking in terms of being the bank here. So here is in my NetBeans example here a class called bankaccount.java. It's the bank account class, and once again, for simplicity's sake, I'm only going to have a few properties. You would probably have more properties in a bank account that you were actually working with, but let's just keep things simple. And let's say that we have an ID number and a name. Both of those can be strings, and then a double precision value for the balance in the account. All right. Now, something that's commonly done in programs where we are working with dollars and cents, dollars and cents would have a fractional part to them, and so we typically would use a double precision value to represent that. But when we print out values, we don't want more than 2 decimal places. And so as you saw in Lab 4, we can use this decimal format class in Java, which will allow us to print things to 2 decimal places like currency. So we'll call this decimal format currency. You'll see how this will work in a second. Okay, so now when we would want to make a new bank account object, right? Remember, we would have a constructor, and so here's a constructor that accepts 3 parameters, one for each of the 3 properties. Okay, so to make a bank account, we could specify first of all a num, which would be the ID number, and then a second string, which would be the person's name for the new account, and then the initial balance. And we would store those parameters in the properties over here. And then also we could set up a new decimal format. This particular string 0.00 means that always the number is going to be printed with 2 decimal places. If it doesn't need 2 decimal places, it'll fill to the right with 0. But it'll round it to 2 decimal places if we use that for printing. Okay. Another thing to illustrate in this demo is that sometimes if you're going to create an account, it might be that we're going to create an account and the person doesn't make an initial deposit, so it would make sense for the initial balance value to be 0. Okay, so rather than have the calling program have to specify a 0 for the third parameter here, we can have a second constructor with a different number of parameters. And that's what we're going to have here. So another constructor, all constructors start with the keyword public and followed by the name of the class. But this one is only going to have 2 parameters, the string num and the string n, which would be the ID number and the name for the new account. And if we don't specify an initial balance, we will assume that it's supposed to be 0 and store 0 in balance. Okay, so this is an illustration that you can have more than one constructor for a class. And then how does the system know which one to use? Well, it'll be determined by whether I specify 2 or 3 values when I ask to make a new bank account in the main program. Okay, so that's constructors. Also then with our bank account class, we would want to have getters and setters. So here are the getters, 3 getters. Get the ID number, get name, and get balance. We would have 3 setters, set ID num, set name, and set balance. And then other methods that we would want to have, well, here's a toString method. Okay, and so this toString method, notice it's going to be returning a string which is a combination of the properties and these actual text strings. So it would be whatever the person's name is, owns account number, whatever the number is, comma, which has a balance of, and then printing the balance using the currency format. That way it won't give me a whole bunch of decimal places. It'll always give me 2 decimal places like dollars and cents. Okay. Now we could work with that. That's enough to work with a bank account. But many times when you are setting up a class, you will want to have methods for the typical operations or transactions or features of the object class that you're working with. So with a bank account, setters are kind of unnatural, like for example, set balance. Okay, when you go to the ATM and you go to withdraw something or to add something, deposit something, you don't have to tell the system what the new balance will be. You know what the amount of the transaction is. I want to take out $50 or I want to put in $100. And the system will take that thing and automatically adjust the balance based on how much you are increasing or decreasing the account. So it would make sense in a bank account class to also add methods for making a deposit and making a withdrawal. Right? So, sorry, I need to change this here. Okay, so to make a deposit, if we specify the deposit amount, let's say we want to deposit $100 in the account, this statement will change balance. It'll take the current value of balance. Remember, with an assignment statement, we always do the right-hand side first. So the right-hand side here is to take the current value of balance plus whatever the amount that's being deposited would be, and that answer should be stored as the new value in balance. So the old balance is wiped out, replaced with this new balance. Okay, so you might think it looks weird to have the same variable on both sides of the assignment statement, but remember, it is directional. We do the right-hand side first, so we use the current value of balance in the calculation, and then where do we put the answer? We store that in balance. That replaces the old value of balance. Similarly, for a withdrawal, if we specify the withdrawal amount, okay, we could do this calculation, take the current balance minus the withdrawal, and then that becomes the new value of balance. Okay, so that makes sense, right, to have deposit and withdrawal. It's going to be easier for the program to work with. Now, if I look at my bank account class, if I look at my MU panel program, here's a program that is going to use these bank account objects. And so let's say I have two bank accounts, account 1 and account 2. Account 1 will make a new bank account, and notice I'm only specifying two parameters here. So the account number 000123, the name is Ricky Bobby, but no third parameter. So that means I'm going to be using the this style of constructor. And if I don't specify a third parameter, the starting balance for that account will be 0. Now for account 2, with Helga's account here, I am specifying a third parameter. Okay, and so the 500 goes in, and that the system will know, okay, 3 values, I need to use this constructor. And so that third parameter will be the starting value of the balance property. Okay, so let me do this. Let me make that a comment so that we don't. Okay, so now, so after I make those two accounts, call the constructor, then I'm going to have some system out printlns. Initially the balances are, and then for account 1 and account 2, I'm going to print the toString. Okay, so if I run the program, okay. Oh my. Oh, I see what happened. Okay. Sorry for that mistake there. And now here in the, notice I have this look in the Java console for output up here. And initially the balances are. So for account 1, Ricky Bobby owns account number 000123, which has a balance of 0. Remember, because I didn't specify a value, so it used that 0 as the default value. Helga Schwartz owns account number 099999, which has a balance of 500. Okay. Oh, why did this get so nice and big, the text in there? Because in my Paint component, I set the font to a larger font, 24-point bold sans serif. Okay, so that's why that was big like that. Okay, now let's do this. Let's say that I want to make some transactions. So for account 2, I'll make a $200 deposit, and I will make a $450 withdrawal. And then after some transactions, let's see what the balances are in the account. Okay. Remember that make a deposit adds that value to the balance. Make a withdrawal subtracts that amount. So let's see. Helga started at 500, and then I deposited $200, so that would be up to $700. And then if I make a $450 withdrawal, 700 minus 450 is 250. Okay. So that seems to be working nicely. Now let's see what happens with Ricky here. If I say account number 1 dot make a deposit. Oh, I don't know. Let's deposit $50. And then account number 1, oops, make a withdrawal. Let's take out $200. Okay. Now, what do you think would happen if you tried to do that at an ATM? You go to an ATM and you have no money in the account, you make a $50 deposit, and then you try to take out $200. It's not going to let you do it, right? Because you don't have enough money in the account to fund that withdrawal. But with our program here, oops, it collapsed my tree, so I need to run this. And uh-oh, Ricky Bobby has a balance of negative 150. Okay, so why did that happen? Well, every time you make a withdrawal, that script or that method is executed from the bank account class, and make a withdrawal, no matter what happens, no matter what the values of balance are or withdraw amount, it's simply going to subtract those two. So the balance was 50, minus 200 is negative 150, and sets that to balance. And so the idea is we need more sophisticated ways to write our programs. In other words, sometimes this is what we want to do. We want to subtract the withdrawal amount from balance, but only if the balance is large enough to keep this from becoming a negative result. And so sometimes we want to do this operation. Other times we would want to print out an error message, something like, hey, you can't do that. You don't have enough money in the account. Okay, so in order to do that, we need a new programming technique, which we're going to see, and this idea is called if statements, or making decisions in our programs. So let's talk a little bit about that, and then we will see the how to do that in Java.